In this lesson, we are going to cover the basics of generative AI and we'll be seeing a couple of topics in the study guide. Basically, jargons related to generative AI and related topics. Without introduction, let's get into it. So what is generative AI? Generative AI, by simple definition, a type of neural network or AI for that matter, can generate new content and ideas. It's a very simple definition or a naive definition for generative AI. In my view, at least, it's much more than that. Especially in the newest model like, for example, Gemini 2.5 Pro or O3 Mini DeepSeek. All these models are showing a type of general intelligence, solving a very difficult original puzzle. Some of these things were, at least at some point in time, we were thinking only can be done by humans. That a very limited number of humans. But these models are capable to do such rare and difficult thinking task. So this is probably a very naive and general way of thinking, but I believe it is much more than that. It generates text, images, and code. Coding is one of the most used functionalities of generative AI these days. For example, someone like me uses this on a daily basis to generate code, verify code, write test cases for existing code and things like that. Coding is a day-to-day bread and butter when it comes to generative AI at the moment. So it creates content. For example, you can create story using ChatGPT. Summarize, you have a bunch of text. If you want to summarize and understand the main points, you can do that. And discover information for you, something like Gemini 2.5 Pro. At this point in time, you can search in Google and get you the information, deep research, etc. Automate, this is where the agent comes in the picture. We will discuss about agents as we progress through this course. Agents are the future. Basically, these three things right here are giving things to us, giving information, or the input and the output is informational. But in this case, automate, this is a separate thing altogether. It is doing things on behalf of you. It is not giving a chat response. It is not summarizing. It is not discovering. It is doing things on behalf of you. Creating a file. If you've been to my other training, AI 102 on the Azure AI, you will get to know that all the samples in the end of the training we are creating things using AI. Model context protocol and things like that, agent. We'll try to do a demo in this training as well to let you see how this things does or automate. But this is a very important functionality of the generative AI at the moment. Doing things on behalf of humans. Next is foundation models. So these are big base models which is trained on so much data. They are very big normally. They can be fine-tuned for different purposes. To create these foundation models, like for example, GPT-4o Mini or GPT-4o or Gemini 2.5 Pro or any such big models, you need a lot of compute, you need a lot of data, you need a lot of specific data which are labeled, unlabeled, a lot of different types of information and compute is required to create these foundation models. Mostly it is done by large companies like Google, Microsoft, OpenAI, Anthropic, DeepSeek, and Meta, and some other companies like Mixtral, etc. create these foundational models. They are very general purpose at this moment, and they are the basis of generative AI. So these are the key features of foundation models trained on large amount of data, something like a Wikipedia corpus, the whole Wikipedia, and much more than that, much more other information, books, a lot of books is being used to train these models. Flexible, they can be used because they are trained on multiple information, huge amount of information. They can be used for a wide range of use cases, very important. And adaptable, you can fine tune this model to be a doctor or a lawyer or a software engineer. That is always the case. When you have a foundational model like Gemini 2.5 Pro, you can fine tune that model. You can even do reinforcement learning and make that model fit for a particular domain through fine tuning. That is what is targeted training here means. A lot of fine tuning can be done. Now, how do we interact with these models? That's where prompting comes into the picture. Prompting is nothing but talking to the model. we are giving information to the model so that the model can predict based on that information we are giving. Prompting is a method of interacting with foundation models or fine-tuned model. It can be any model out there, fine-tuned or foundational. We are giving input to the model so that it can give an output. So it involves providing them with instructions or input to generate desired output. I think there are different types of input like context, system input or system prompt, and a normal prompt, etc. I think it is outside the scope of this particular training, but if you're interested, you can ask me questions, and there are other trainings from me which explains all these things in detail you can check out. But otherwise, in simple sense, prompting, one of the most important thing to make the model do some work on behalf of us. If you have used ChatGPT or Gemini or any other models or chatbots, you know already what prompting is. It is nothing but a fancy way of saying talking to the model. Prompt engineering. This is one of the major areas of study these days. Prompt engineering, making the model do specific things, kind of like command to the model. There are certain things we have to do in a certain way when it comes to prompting. That's where the art and science of creating effective inputs known as prompts for generative AI to maximize, this is a point here, maximize their value and very good response to specific needs. Probably you can get it done in many ways, but if you can get it in one prompt, it is very cost effective. And in one shot, you can get a lot of things done by the model and save a lot of cost, time, and effort if you know how to prompt the model correctly. So that is prompt engineering. If you want, you can search. There are a lot of tips and tricks. It differs a lot between different models as well. For example, a prompt engineering technique works with Gemini, may not work with OpenAI or Anthropic or any other model, may or may not. But a lot of these techniques these days are very generic and works with a lot of models. Unfortunately, there are a lot of topics in this particular document we are going through is a little bit unordered, but we have to put up with it because this is the study guide of the certification we are trying to focus on. Just after foundational models, they are talking about labeled data and unlabeled data, which is kind of a different topic altogether. There's nothing directly to do with generative AI. So these are all very ML related concept, machine learning related concept. Yeah, it is true that machine learning is what generative AI uses, but these topics are slightly out of context, but we have to discuss it anyway. But one thing I would like to tell you is that I would like to switch the gears a little bit so that I can discuss this labeling and unlabeling data. Now, coming back to machine learning. So we are not talking about generative AI in specific right now. We are talking about machine learning all of a sudden because of the nature of this document. Coming to machine learning needs data. So you have a model, can be a neural network or normal model. Remember, the model is not trained in the beginning. The weights and bias has random information. So you need to give data, you need to give input to the model. Think of it like a new joinee in your organization or a student in a class. He doesn't know anything. You have to give him some information. You need to teach him something. You are showing a picture of letter A and telling him that it is letter A. So let's get in the blackboard and trying to understand what we are talking here. So we are going to discuss labeled data and unlabeled data. So that's the topic of our discussion. Suppose we are teaching a student and we have letter A here and we are telling him letter A. So the student is able to understand because we are telling him that it is letter A. So this is a labeled information right now we have. Labeling. So there is an image of letter A. So let me draw that in a different color. This is the letter A image and we are telling him it is A. So this is a labeled information. Now there is a classroom which the student is there. This is a classroom which the student is present and there are a lot of things in the classroom. There is chair, there is a TV, there are so many desks and things like that in the room. There's a wallpaper. There are so many things in the room and the student is standing in the room. So this is the student standing in the room. Now he's seeing a lot of new things in the room and he's learning certain things by himself. It's the same student. It can be the same student. Now that is unlabeled data. So he is learning by himself. He doesn't know what it is. So a model also can do the same mechanism. You can learn from labeled information, which will be easier to understand and learn, labeled data. But at the end of the day, you can learn also from patterns. Suppose I'm giving you a pattern 2, 6, 10, and 14. Even though I'm not labeling this particular pattern right here, you can get to know it is x plus 4, while x is the previous digit. So this is a unlabeled data. So these data are not labeled, but there is a relationship between them, and we can find that relationship here. So that is the difference between labeled data and unlabeled data. Mostly these days, all the top models are trained with labeled data. So this is what it is, labeled data, a data that has been associated tags such as name, type, or number. Unlabeled data, just like we mentioned, raw unprocessed information that hasn't been tagged. So it could be photos, streams of audio, it can be any information. And the model is supposed to look for patterns within this unlabeled data. Now, this corresponds to two different type of training or learning mechanisms or algorithms. Supervised learning trains the model based on labeled data. So you are telling A and giving a picture of A. Like that, you're telling B and a picture of B, or multiple pictures of B. So that is what is supervised learning. It's very effective, very to the point. Most of the time, supervised learning will lead to fast convergence, which means that the model will get trained very easily with supervised learning. Unsupervised learning uses unlabeled data to find natural patterns and groupings. In fact, initially, the LLMs are trained a lot on unsupervised learning using Wikipedia corpus and things like that. You are simply giving input from the whole data of Wikipedia from the internet. Some 30-40 TB of text information, pretty much the whole information in the world, at least a good subset of it. So that is unsupervised learning. Then there is this very interesting reinforcement learning. I would say it is kind of in the middle of both of these things. The idea is this is nothing new to us. This is something we do all the time. Mostly this is all about you're trying to do something, you know what we want. For example, a tennis serve. You know it has to pitch into the corner box of the tennis court on the other side. That's the main objective. And you have to stand outside the baseline if you're into tennis. So your objective is pretty clear. Now you can do all kind of hitting and missing and trial and error to get that shot right. You're spending days, weeks, and sometimes months and years to get that shot right. It's one of the difficult things. If you're into tennis, you know how difficult a tennis serve is to get it right. A professional tennis serve is literally impossible to nail down. So that is a reinforcement learning. You don't have pretty much any data at all. You have an objective and there are certain ways to get to that objective. You are trying different alternate paths to get there. Clear objective. So this is being used for a lot of different types of scenarios in which the thinking model recently is using reinforcement learning for math kind of problems, logic, reasoning, all this kind of areas in which your objective is pretty clear. Now you have to try different paths to get there. That's what reinforcement learning. Playing chess, for example, AlphaGo and AlphaZero, they are chess engines. They have used reinforcement learning to learn chess. Initially, they don't know any strategies and tactics to know chess. Only the rules of chess. They're playing each other. They play to themselves over and over again. And they learn from the strategies and tactics. The only objective is to checkmate the king. Everything else, it is finding out from trial and error. Keep playing by themselves. So there is no other information we are giving. There is no data. Not labeled data or unlabeled data. Only there is an objective. You keep practicing. You keep learning yourself to achieve the objective. So that is reinforcement learning. Learns through interaction and feedback. Feedback in the sense, if you're not reaching the objective, your reward is very, very less. If you're reaching the objective, that's when you get the reward. That's what feedback. To maximize the reward and minimize penalties. So when you reach the goal, you will get reward. and minimize penalties. That's what reinforcement learning. So we have seen some of the basics and jargons related to generative AI or AI in general. Let's continue our learning, and I'll see you in the next lesson.